Hello there, students. Welcome to Grade 9 Mathematics. I am your teacher, Sir John. In today's lesson, I will discuss to you the first lesson entitled Illustrations of Quadratic Equation. Do you know that there are so many practical applications of quadratic equation in the world beyond our school? Uses of quadratic equations includes explaining how planets in our solar system revolve around the sun. Do you know that Isaac Newton based his laws of motion on the quadratic equation? It is also used by car makers to determine how much and what type of brakes are needed to stop a car going at various speeds. Also, quadratic equation used in the design of almost every product in our stores today. The equation is used to determine how safe the products and the life expectancy of the product. So those are some life situations on which our topic can be applied. Now, before we start the discussion, please prepare your mathematics module and your pen and paper. Here are the objectives of our lesson. Number 1, differentiate quadratic equation from linear equation. Number 2, writing quadratic equation in standard form and identifying the values of a, b, and c. Number 3, formulate a quadratic equation to represent the given real-life situations. So let's have a review on the special products and linear equations. Special products, letter A. Product of monomial and a binomial. I prepared two examples here. A times quantity C plus D and A times quantity C minus D. So we can use the distributive property of multiplication to determine the product of a monomial and a binomial. So step 1, we're going to distribute A to each of the terms in the binomial. A times C is AC, and A times positive D is positive AD. So our final answer is AC plus AD. In the next example, A times quantity C minus D. The difference in this example is that the operation in the binomial is subtraction. A times quantity A times C is AC. A times negative D is minus AD. So let's have an example. 2 times quantity x plus 3. Using the distributive property, multiply 2 to each of the terms inside the parentheses. So 2 times x will give us 2x, and 2 times positive 3 is positive 6. So our final answer is 2x plus 6. Next example, 3x times quantity x minus 4. So the monomial is 3x multiplied by x. Since we have the same literal coefficient, x times x will give us x squared. So 3x times x is 3x squared, and 3x times negative 4 is negative 12x. So our final answer is 3x squared minus 12x. Special product, letter B. Product of two binomials. So we have here quantity x plus a times quantity x plus b. We can use two different methods here. First is the distributive property or the FOIL method. Say for example, we will use the FOIL method. F stands for first terms. So x times x is x squared. O stands for outer terms. So we're going to multiply x and b. That will give us bx. I stands for inner terms. So a times x is positive ax, and the last terms, a times b, is positive ab. Now the second and the third terms have the same literal coefficient, so we can simplify this one. So x squared plus the sum of a and b multiplied by the literal coefficient x plus ab. So let's have an example. Quantity x plus 3 times quantity x plus 5. Using the method I discussed earlier, x times x, or the first terms, will give us x squared. X times positive 5 is positive 5x. 3 times x is 3x. And 3 times 5 is 15. Now the second and the third term have the same literal coefficient. So we are going to add the two numerical coefficients, which is 5 and 3. So our final answer is x squared plus 8x plus 15. Square of binomial. We have a square binomial quantity a plus b squared. We can expand this into quantity a plus b times quantity a plus b. Using the distributive property of multiplication, or the FOIL method, a plus b times a plus b will give us a squared plus ab plus ab plus b squared. Notice that the second and third term are the same, so we can simplify this into a squared plus twice the product of a and b, or 2ab plus b squared. So let's have an example of a square binomial. Quantity x plus 5 squared can be expanded into quantity x plus 5 times quantity x plus 5. So using the method I discussed earlier, so we will have x squared plus twice the product of 5 and x. We will have 2 times 5x plus 5 squared. To simplify this, the final answer is x squared plus 10x plus 25. Let's have a review on linear equation. When you are in grade 8, you discuss about linear equations, its practical applications, and its graph. So here is the definition of a linear equation. A linear equation in one variable is a mathematical sentence of degree 1 that can be written in the following standard form. Ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Notice that the x here is the variable and the highest exponent of x is 1. That's why it is called in the degree of 1. Let's have an examples of linear equation. 2x plus 4 equals 0, x equals 5, 3 equals negative 4a. The literal coefficients, or the variables in these expressions, are x and a. Looking at the variables, the highest exponent of each variable is 1. So this is called a linear equation. Now let's go to our main topic about quadratic equation. Here is the definition of a quadratic equation. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form. Ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a must not be equal to 0. The first term, ax squared, is called the quadratic term. The second term, bx, here, is called the linear term. And the last term, c, is the constant term. Take note that the value of a must not be equal to 0 because it is the numerical coefficient of the quadratic term. What will happen if a is 0? So if we're going to substitute 0 to a, it will be eliminated, the first term, and we only have bx plus c equals 0. Then it will not be considered as a quadratic equation because it has no degree of 2. Quadratic or not quadratic? Let's determine which of these 5 expressions here are quadratic or not quadratic, or can be a linear equation. Number 1, 5x squared plus 2x plus 4 equals 0. We all know that linear equation is in degree of 1. Quadratic equation is in the degree of 2. Number 1, by looking at the variable, the highest exponent of the variable x is 2 because the first term, the exponent of x is 2, the second term is only 1. So this is an example of a quadratic equation. Number 2, 5 minus 4x equals 0. The variable x has an exponent of 1. So this is a linear equation. Number 3, this is a quadratic equation because the first term x has an exponent of 2. Number 4, 3x plus 34 equals 0 is a linear equation because x has an exponent of 1. Number 5, x plus 4x equals 0. The variable x has a highest exponent of 2, which makes it as a quadratic equation. So it is very easy to determine which of the terms or equations are quadratic or linear equation. Now let us transform quadratic equation into its standard form and find the values of a, b, and c. So are you now ready? Example number 1. Directions. Write each quadratic equation in standard form. Ax squared plus bx plus c equals 0. Then identify the values of a, b, and c. 2x squared plus 5x minus 4 equals 0. By looking at the equation, this is already on its standard form. So we can now find the values of a, b, and c. A, here, the value is 2. B, the numerical coefficient of the second term or the linear term is 5. And the constant term is negative 4. Example number 2. 3x times quantity x minus 6 equals 15. In order to write the expression into standard form, let us multiply the monomial times a binomial. So 3x times x is 3x squared. 3x times negative 6 is negative 18x equals 15. We should make this right hand side of the equation equals to 0. In order to do that, we're going to subtract both sides of the equation by 15. So we'll have 3x squared minus 18x minus 15 equals 15 minus 15. The right hand side of the equation will become 0. So our final answer is 3x squared minus 18x minus 15 equals 0. It is now easy for us to find the values of a, b, and c. A is 3, b is negative 18, since because of this operation, negative minus, and c is negative 15. So don't be confused on the operation used. For example, in this last term, the operation used is minus. So meaning to say that the last term or the constant term is negative 15. Example number 3. Quantity x plus 4 squared equals 5. In the special product, this is a square of binomial. So we're going to expand this one. So we'll have x squared plus twice the product of x and 4. So that is 8x plus 4 squared is 16 equals 5. I just follow the special product in multiplying square of binomials. To make it in standard form, we make sure that the right hand side of the equation is equal to 0. We're going to subtract both sides of the equation by 5. We'll have x squared plus 8x plus 16 minus 5 equals 5 minus 5. This will now becomes 0. So our final answer is x squared plus 8x minus 11 equals 0. So the value of a is 1. 1 because the literal coefficient of x squared, though it has no number here, it is understood to be 1. b is equal to 8 since the operation is plus. And the constant term is negative 11 since the operation is minus. Example number 4. X times quantity 2x minus 4 equals quantity x minus 3 times quantity x minus 3. In the left hand side of the equation, we have a monomial times a binomial. And in the right hand, we have a binomial times a binomial. We're going to use the distributive property in simplifying this expression. Here, x times 2x is 2x squared. X times negative 4 is minus 4x equals x times x is x squared. Since this is a square binomial, twice the product of x and negative 3 is negative 6x, and the square of negative 3 is positive 9. Next step, we are going to combine like terms. 2x squared and x squared will be combined. So we're going to move x squared to the left hand side of the equation. So it will make 2x squared. Since this is positive, if it moved to the left side, it becomes minus x squared. Copy minus 4x. Minus 6x here will be moved to the left hand side of the equation. It becomes positive 6x. And positive 9 will become minus 9 equals 0. So this is just a shortcut method in order for us to simplify this expression. So 2x squared minus x squared will gives us x squared, and negative 4x plus 6x, since they have unlike terms, we're going to subtract the numerical coefficient. Negative 4 and positive 6 will gives us positive 2. Just copy their literal coefficients, which is x, and copy negative 9. So our final answer is x squared plus 2x minus 9 equals 0. And we're able to find the values of a, b, and c. A is equal to 1, b is positive 2, and c is negative 9. There are some cases that we can consider as quadratic equation. When b is equal to 0 and ax squared plus bx plus c equals 0, when we substitute b as 0, then it will become ax squared plus c equals 0. Though this is not the same as the standard form because it's lacking the linear term, but we consider this is a quadratic equation because of the presence of the quadratic term ax squared because of the degree 2. Example, 2x squared minus 2 equals 0, x squared plus 11 equals 0, and negative 3x squared minus 6 equals 0. All of these three expressions has a degree of 2, then these examples are called quadratic equation. Case number 2. When c is equal to 0 and ax squared plus bx plus c equals 0, then we will have ax squared plus bx equals 0. Though we don't have a linear term here, it is also called a quadratic equation because of the presence of the quadratic term ax squared. Examples are x squared plus 2x equals 0, negative 3x squared minus 6x equals 0, and 4x squared minus 4x equals 0. So these three expressions here are also considered as quadratic equation. Let's have quadratic equation can be written in two ways. Let's have an example. Negative 8 plus 7x equals 5x squared. So we're going to rearrange this expression to become a standard form. Now, we can move the negative 8 plus 7x to the right hand side of the equation by subtracting negative 8 plus 7x to each of the side of the equation. So let's have negative 8 plus 7x minus quantity negative 8 plus 7x equals 5x squared minus negative 8 plus 7x. The left hand side of the equation will now become 0. And we'll have 5x squared minus negative 8 plus 7x. We're going to simplify this parenthesis. So it will become 0 equals 5x squared. Now this is minus here. And the sign of 8 is negative. So it will become positive 8, negative and positive 7x. So negative times positive is negative 7x. And rearranging this one using the symmetric property, we'll have 5x squared minus 7x plus 8 equals 0. The values of a is 5, the values of b is negative 7, and the value of c is 8. We can also eliminate the 5x squared in the right hand side of the equation and transfer or move it to the left hand side of the equation. So we will just subtract each of the equation by negative 5x squared and negative 5x squared. So it will become negative 8 plus 7x minus 5x squared equals 5x squared minus 5x squared. This left hand side of the equation will become 0. Then we'll have negative 8 plus 7x minus 5x squared equals 0. Rearranging this one, it will become negative 5x squared since the operation of 5x squared is minus, so it is negative, and positive 7x and minus 8. So the values of a, b, and c are negative 5, b is 7, and c equals negative 8. Though they don't have the same form because of the quadratic term of this first equation is positive and here is negative, so the operations are opposite. We can consider this also a quadratic equation in standard form. Looking at the values of a, b, and c, they are opposite. So depending in your teacher on what equation that you are going to use, either the first term or the quadratic term must always be positive, then you must follow this procedure here. But if your teacher says that you can have either positive or negative quadratic term, then each of these method or each of these equations are correct. Now let us move on. Some situations that illustrate quadratic equation. Number 1, word problems. Number 2, rectangular area problems. Word problems that involve multiplying the number by itself can be considered as quadratic equation. For example, 3 times the square of a number added by the number is 14. Say for example that number is x. These word problems can be translated as into mathematical sentence 3x squared because of the word square of a number, plus because of the word added by the number. So we have here x is 14. So these word problems can be translated as 3x squared plus x equals 14. Now let's make this mathematical sentence into a standard form. So we just move this linear term here 14 to the left hand side of the equation. Then we will have 3x squared plus x minus 14 equals 0. So the values of a, b, and c are 3, 1, and negative 14. Now let us go to rectangular area problems. Since area of a rectangle is given is equal to the product of the length and the width, or A is equal to length times width, then word problems that involve area uses quadratic equation. For example, the length of a rectangular pool is 2 meters more than its width. The area of the pool is 80 square meter. So the length of the rectangular pool is 2 meters more than its width. Say for example that width is x, then the length can be translated as 2 plus x. So we have here the formula for rectangle. A is equal to length times width, then substituting the given area which is 80. So we have here 80 equals quantity 2 plus x times x. Simplifying this expression, it will give us 80 equals 2x squared plus x squared. Now, making this into standard form, let's move this 80 to the right side of the equation. So we have x squared, rearranging the terms, x squared plus 2x, positive 80 now becomes minus 80 is equal to 0. So let's have the dimension of the pool. So for example, this is the pool with area equals 80 square meter. The width is x and the length is 2 plus x. Given by the standard form, x squared plus 2x minus 80 equals 0, we are going to solve for the value of x. How are we going to do this? We're going to factor this equation. So we have x plus 10 times x minus 8 equals 0. How to check this if it is the factor of this equation? By using the property that I discussed earlier. By multiplying these two binomials, we can get this quadratic equation x squared plus 2x minus 80 equals 0. Solving this using the zero product property, x plus 10 equals 0 and x minus 8 equals 0. As you see, we equate each of the factors by 0. X plus 10 equals 0, it will give us x equals negative 10. X minus 8 equals 0, it will give us x equals 8. Now we are dealing with measurement, so we will only use x equals 8. So x equals 8, then the width is x equals 8 meters, and the length is given as 2 plus x equals 2 plus 8 equals 10 meters. Therefore, the dimension of the pool is 8 meters and 10 meters. If we're going to check if this is correct, if the width is 8 and the length is 10. By multiplying the two, we'll have an 80 square meters. Alright, now let's have the summary of the lesson. Let's differentiate linear equation from quadratic equation. In linear equation, this is mathematical sentence of degree 1 that can be written in the following standard form: ax plus b equals 0, whereas the quadratic equation is in degree of 2 that can be written in ax squared plus bx plus c equals 0. So it is very easy to differentiate the two because of this statement here, the degree in linear degree of 1, in quadratic degree of 2. Take note that the a, b, and c are real numbers and a must not be equal to 0. Definition, standard form, and identifying the values of a and b and c for quadratic equation. As what I've said earlier, that quadratic equation is of degree of 2, and the standard form for quadratic equation is ax squared plus bx plus c equals 0, where a and b and c are real number and a must not be equal to 0. How to identify the values of a and b and c? So first, we're going to transform the equation into a standard form by using the special products or any of the properties or any of the methods that I discussed earlier. For example, negative 3x squared plus 5x minus 11 equals 0. So this is in its standard form. We can now find the values of a, b, and c here. A is negative 3, b is 5, and c is negative 11. So all of these quadratic equations, the definition, standard form, and identifying the values a, b, and c are discussed in this lesson. So thank you, class, for listening. I hope that you enjoyed this video and you learned something about our lesson to help you answering your modules. May this video will enhance your knowledge and mathematical skills. For our next video, we will discuss about the quarter 1 week 2 module 2, which is solving quadratic equations, and module 3, which is nature of roots of quadratic equation. Thank you, students, for listening, and have a good day.